Right, do you remember that shenanigans? Well, okay, that was correct. That was 11A. Now we're going to tackle 11B. Hopefully it won't be another 14-minute video. In other words, roughly 28 minutes just for one question is crazy. Now it doesn't take that long to do it, obviously, but obviously to teach it and give you the background and the rest it does take a little time. What I'm doing is now 11B. It says what is the area of the sheet of metal that is needed to make this grain hopper. So what I've got basically is a cylindrical top. So, and again there's a hole there, so there's nothing there whatsoever. So what I need to do is to work out the surface area of this part going all the way around the curved surface of the cylinder, and there's a formula for that. And I need to work out the curved surface of a cone as well, except it's not a cone, it's a frustrum. So I'll be transferring this information here next door. Bam, there it is, as if by magic. So there it is. Essentially, let's just break it down. I need the surface area of the curve here, and we know the curved surface area is going to be 2 pi r h. Remember, 2 pi r is like the circumference that was, and h is the height. So straightforward really. 2 pi r h is just the curved surface alone. And for the two cones we're looking at pi rl. There's 2 pi rls though. Let's put the word area as well. Put it there. Is going to be pi times r times l. So these are the two formulae I'm using. So what I've got here is pi rl for the great big cone that's not been broken up yet, and I need to do another little pi rl as well for the smaller one. Okay, so again a little length there as opposed to the great big slanted length there. Now as you can see, I don't know what L is going to be at all because I need to use Pythagoras to work it out. So if I'm going to work out the length there, I need to calculate it using Pythagoras. And as you can see, this length here from that center right to the tip of the cone is going to be 140 centimeters from before, and there it is. So 140, although I've drawn it outside the shape, is not the hypotenuse, it's just one of the shorter lengths from there to there. And of course the radius of 50 is the other shorter length. So let's just work out L quickly. Here we go. So big L is going to be 140 squared plus the 50 squared. That's Pythagoras, and then you square root it, and we'll get an answer for that right now. I think I've got it. Yes, there it is. And that's going to be 148.66 centimeters. Okay, trust me. 40 squared plus 50 squared, press equals, hit the square root button, and that curve length is going to be 148.66. So therefore, let's just change colour for the curved surface. So therefore, doesn't show, does it? Let's do it in red. Therefore, surface area is going to equal, and I will do the rest of it in yellow as it shows. It's going to be pi times the radius times the length, so 3.14 times the radius of 50 times the slanted length there from there to there, 148.66. That gives us a final answer of 23,339.73 centimeters squares worth of surface metal. But of course the bottom part doesn't actually exist, but I need to work it out so I can calculate it and then subtract it from the overall cone, and therefore just get the surface of the frustum there. Okay, so now I need to work out the little L, which is from here to here. I know the height is 70, I know the radius is 25, so I will revert to blue again. So the other little L is going to be whatever it's going to be. It's going to be the 70 squared. Again, it's not the slanted length, it's the vertical height 70, so it's one of the small sides, plus this part here, the other small side of the triangle, 25 squared. Then I need to square root it, and that will give me, I've worked it out before, yeah, there it is, 74.33 centimeters, and therefore the surface area of these small cones is going to be pi rl. Again, it's a different L, so it's 3.14 times a radius of 25 multiplied by the length from there to there, which is 74.33, and that gives us all 5,834.93 centimetre squares worth of surface. So I can now subtract the two values. I can subtract this one, oops, it should have been black, subtract that one and that one to give me just the area of the frustum there. So therefore, area of curved part of the frustum is going to be this, 23,339.72, take away, which is the whole thing actually, take away the area of the small part, 5,834.93, and that will give me a certain answer, won't it? Let's just do that, because I did it on my calculator before. Again, I did it in fewer steps. 23,339.72 take away 5,834.93, and hopefully that gives the right answer. Bam. Right, I've got here 17,504.79 centimetres squares. So I've got that. Now let's just work out the surface area of the top part of the cylinder. We'll do it up here because there's lots of space here. That's going to be 2 times pi, 3.14 stands out, times the radius of 50 from there to there, there it is, times 50, 2 pi r times the height of 80. Very, very easy. Whack it in, and I worked it out earlier, 25,120 centimetres squares worth of area. So I've got this part here sorted, I've got this blue part here sorted, but there's just one thing missing. Remember, the bottom part right here, which I shaded nice and dark, is in fact solid. If there was nothing there, the grain would fall straight through onto the sand there in Weymouth Bay. So we can't have that. So really I need to work out the amount of metal needed to make the small circular base at the bottom. Really, really easy, because the formula is pi r squared. So area of circular base of the frustum is given by pi times radius squared, so 3.14 times the radius squared, just took 25 across there, 25 squared, and I hope I worked that one out, if not I have to do it from scratch. Yes, I did, well done me. That's going to be 1,962.8. I can barely read it. I think I'll do it again, I can't see it properly. So it's 25 times 25 times pi, 0.5, yeah, okay, I can see that. So 0.5 centimetres square. Now I'm going to change it to black for the final punchline, because now I can work out the entire thing. I need the area of the curved surface of the cylinder, I need the area of the curved surface of the frustum, and I need the area of the base of the frustum. They're the three parts. Okay, part 1, part 2, and the little one down there, part 3. So here we go. Total surface area is going to be, area is going to be that plus that. Again, we'll round it off later, plus that, and it's probably crashed into my picture, hasn't it? Stupid thing. And that will give us a grand total of, where are we? 44587.3 centimetres squares. And again, if we divide by, what do we need there? If I divide by 1,000, doink, 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 no, 10,000, doink, yeah, 10,000, doing, 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 yeah, and that will give me 4.46 metre squares of metal required. What does the question say? What area of sheet metal is needed to make the hopper? Alright, so we got here of metal needed. And of course I did that to 3 significant figures. Alright? Right, isn't that hard? Well, there's no time to do that in an exam. Certainly you can't do an 11A like that and an 11B like that. I mean, it takes ages. So that's it. That's the correct answer. 4.46 meters squares worth of sheet metal required to make that. It doesn't say you've got to give it in meters squares. See, I could have stopped at this level really and got the final answer, got all my millions and millions of marks. But 4.46 is good. That's correct. I'm so glad that's over. I really did have to prepare that one beforehand. And imagine me doing this live. I'll make so many mistakes and it's just not worth it. So enjoy that one, and you probably won't get one of those. But what great questions to do in class. What a great question to challenge your brain and to exercise your brain. It makes Unit 3 seem absolutely easy, doesn't it? Right, see you later.